Hey, Disha.
Hello.
So, have you ever been in that one building in Clemson that, like, literally does not have a single women's restroom?
Isn't it like the second half of like Martin?
Yeah, it is. It's like that. It's always weird. I don't know what they do in there, but regardless, you have to go all the way to like the building over
Yeah.
to use a bathroom.
Yes.
So imagine going to like work or school or whatever, and that's normal. Like men's bathrooms are everywhere, but you have to walk across like the street at the very least, like leave the campus to even find a bathroom.
Mm.
Now, imagine trying to do something like really important to like change the world type stuff, and you have to walk across the street to go to a bathroom.
AKA Katherine Johnson in Hidden Figures.
Yes. Yes.
Where she has her whole meltdown. Meltdown sounds bad, but it's warranted over how she has to walk a mile each way and walk because she can't use bikes because she has to use the colored bathrooms.
They did that movie scene so well. Yeah.
Mm-hmm.
But yes, okay. So second question. Do you know what nuclear fission is?
I feel like I should. I've taken physics.
Fission versus fusion.
Fission? Oh, hold on. This is like alpha particles and beta particles and positrons and...
Basically. Well, that's just nuclear.
Okay, wait. So fission is it breaks apart. Fusion is it gets together. Nuclear fission is when one atom is like, no, I'm two now.
Fission, yes. Yes. You did that.
Is it the atom or is it the element? It might be the element. No, nuclear is nuclear. So nuclear is...
Yeah.
Nuclear is the atom is like... I don't know.
No, you got it. You got it.
Did I really?
Don't overthink it.
Okay.
Fission, one splits into two.
But how does an atom split into two?
Well...
Because the atom is the smallest unit of matter.
I don't know, but the nuclei splits, okay?
Okay.
So, regardless of our understanding of it, this is the woman who literally discovered...
Nuclear fission?
Yeah!
Oh wow, that's cool. I didn't know that.
I didn't either. Okay, so this is very like German pronunciation, so I'm probably gonna butcher it, but Lise Meitner?
Meitner?
That, yeah. Lise Meitner was the third of 8 children born in November 1878 in Vienna, Austria, to chess master Philip Meitner, whatever, and his wife Hedwig.
Hedwig! Like from Harry Potter?
Yes.
Like the owl?
Yes, her mother was Hedwig the owl.
Okay, I don't know if other people know this, but Hedwig was a girl. Everyone just like assumes because he's an owl, he's a boy.
I thought it was a girl.
No, Hedwig's a girl.
Yeah.
It's a she.
Yes. Wait, Hedwig in the movie, is it a boy?
No, it's a girl.
Okay.
But
okay,
like I feel like people
sure.
just like assume that she's
she's
he.
Okay.
Anyways,
Yeah.
Hedwig! I was literally watching everybody yesterday and Hedwig died!
Okay. Well, this was the 18th century, so. Anyway, so her parents were Jewish and like relatively upper middle class, and the actual date of her birth is actually highly debated, which is strange. But so the birth registrar of Vienna's Jewish community lists her birthday as the 17th, but all like other documents list her date of birth as the 7th, and she like used the 7th as her birthday in records.
Interesting. Something similar happened to my grandmother.
Oh,
so she
wow.
was born before they had like formal records, and she was born in a village. And so when like India became no longer under British rule, they had to go and like officially like be like, when were you born?
That's crazy.
And she doesn't remember. So like I remember there's a point in time we were like, is she 80 or is she 83?
Oh my god.
Like we didn't know what year she was born in. I'm not even sure if my dad knows what year. I'm not even sure she knew what year she was born in.
That's insane.
Yeah. So that happened.
Wow.
Yeah.
Wow.
But back to Elise. So her father was one of the first Jewish lawyers who were allowed to practice in Austria. Elise and all of her siblings pursued what was considered an advanced education at the time. Her dad was considered a free thinker, meaning he didn't allow traditional social or religious beliefs.
He didn't follow.
Oh, he didn't.
He didn't allow them. He did not allow tradition.
No, sorry, he didn't follow traditional social or religious belief systems. He encouraged all of his children to get an education, even though it didn't follow what was traditional at the time.
So, even though her father raised her as like a quote-unquote free thinker, Elise ended up converting to Christianity later in life, following Lutheranism, and was baptized in 1908. So 2 of her sisters also converted to Catholicism in that same year.
Catholicism?
Catholicism. I was having trouble with that word, okay? But yes, religion. They liked religion.
Interesting.
So Elise also chose to go by like a shortened version of her name, which is just Lise. So we'll be referring to her as Lise in this episode. But anyway, back to her childhood.
Lisa's interest in science started when she was 8. She would keep a little notebook of her scientific research right under her pillow. She really liked math and science and studied the colors of oil slick and think films.
I think that's supposed to say thin films. I just can't type.
I see.
Yes.
And reflected light. At the time, the only career available to women was teaching, as we have mentioned so many times before in this podcast. They were all teachers because that's the only thing they could do. But she attended a girls-only school for girls.
You can talk about the episodes.
But she trained as a French teacher. Other than French, she studied bookkeeping, basic arithmetic, which me and Eva can't do, history, geography, science, and gymnastics. I'm also real curious what gymnastics look like.
Oh, it's not that type of gymnastics.
Oh. Okay. Okay.
We'll get into it a little bit.
Very well. But she finished high school in 1892.
So, yes. So until 1897, Vienna banned women from attending public institutions of higher education. So when this restriction was lifted, the requirement for a gymnasium education was waived. So a gymnasium is a term in few European languages that basically means a secondary school that prepares students for higher education at university. So technically, because I think she was becoming a teacher, she had to like learn how to be a teacher. So it was like a requirement that she like. That's kind of my understanding of that.
I see.
But at the same time, like for her to go to like a real university as like the men would, she would have to go through a secondary education school that was like based on preparing you for true university. So it's comparable to like the US term college prep school or academy.
I see.
And grammar school in British terms.
I see.
So before the 20th century, the gymnasium system was like super common and kind of everywhere. Especially in like European countries, but they kind of like did away with it, honestly.
So even though the requirement prep school in order to go to the higher education was no longer, they still wanted women to pass the matura, which is like the exam you would take at the end of prep school. Lisa's sister, Gisela, passed the matura and went to medical school in 1900. Lise didn't feel prepared right away, so Lise and 2 other women in 1899 began cramming for it, since they didn't get a really, like, true secondary education. They pretty much crammed secondary school into 2 years worth of private lessons.
It's kind of crazy.
It's insane.
Yeah, so in July 1901, they took the matura at a very German gymnasium, a very German school.
Academiches.
Why do I feel like...
Academiches.
Yes. Well, they went there to take the matura, kind of like how in high school we would go to like schedule our SAT or ACT and we would take it somewhere else. So out of 14 women who took the exam, only 4 of them passed, including Lise, obviously, but also notably Henriette Boltzmann, who was the daughter of physicist Ludwig Boltzmann.
I feel like that name sounds familiar.
It does. I don't necessarily remember why. But after passing the matura, Lise started at the University of Vienna in October of 1901. She was inspired by Ludwig and often talked about his lectures and was like really interested by him. I think he has a hand in like some part of her research later, but we'll get to that.
Sorry, I'm like tripping over Boltzmann because I feel like
it's a very unique name.
I feel like I've heard it in physics. I think it's like an equation or a constant.
Yeah, it's like the Boltzmann equation or something. It's definitely something.
So Lise's doctoral dissertation at the University of Vienna was titled Thermal Conduction in Inhomogeneous Bodies and received her PhD in physics in 1906. She was the second woman to earn a doctoral degree in physics at the University of Vienna after Olga Steindler. Yes, who had received her degree in 1903. Paul Ehrenfest, who was also a theoretical physicist, asked Lise to do further research based on an article on optics by Lord Rayleigh. Rayleigh's experiments that had produced unexplainable results.
Yeah, so Lise was able to explain his unexplainable results, and she made predictions based on her explanation, which she then verified experimentally. So this gave her the ability to carry out independent and unsupervised research, and now everybody believed that she could do that. She published the results in her report on some conclusions derived from the Fresnel reflection formula. While she was working on that project, she was introduced by Stephen Mayer to radioactivity, which was a brand new field of study. She started studying alpha particles. In her experiments with collimators and metal foil, she found that the scattering in a beam of alpha particles increased with the mass of metal atoms.
Wait, is this not how they found the proton, the nucleus of?
Wasn't that the one where they shot
the
a bunch
gold
of things?
foil thing? Yeah.
Yeah.
Is this different?
I think slightly. I can't necessarily explain how.
I see.
But I do believe it is different.
I see. Okay. So her findings were submitted to a German scientific journal named Should
stop trying to pronounce things.
I'm so sorry if you're German and I messed that up, but they published on June 29th, 1907. Rutherford! This was the Rutherford. Okay, I wasn't going crazy. Okay, so this was one of the experiments that led Ernest Rutherford to predict the nuclear atom. This is what I was talking about with the gold particle. Okay. I'm not crazy. No. I know physics. Even though Lise was already well educated, with her father's encouragement and his wallet, she went to Friedrich Wilhelm University in Berlin. I feel like I'm screaming today. So if you ever heard of Planck's number, what is Planck's number? Planck's constant.
Girl.
It's and the quanta, I don't know what the quanta is, but I do know what Planck's constant is.
His constant is quanta. It's like one unit of atom, and it's like XYZ, or one thing, and it's like XYZ, a number of...
I see. Well, Mr. Max Planck taught at this university, and he invited Lise to his home. That sounds a little weird. And allowed her to attend his lectures. So this was huge because he was well known. He was Planck, of Planck's constant. And...
he was already famous at this time.
That's crazy. Imagine meeting the Planck.
Right.
But he was super well known, so this was really big. Because he was well known on the record for opposing admissions of women to universities in general, but here he is inviting a woman into his house that is educated at said university.
Exactly. He was a woman hater, but he did not hate Lise. She was an exception to his rule. She even became besties with his twin daughters. They talked about music a lot, apparently.
I see.
But whenever she wasn't attending Planck's lectures, she was working in the research lab of the head of the Experimental Physics Institute, Heinrich Rubens.
That one wasn't that bad.
No, they scare me sometimes. She was
Heinrich!
Well, if you say it like that.
My French teacher always says everything with a really aggressive German accent. And she'll just randomly pull German words out, and she'll go and have to...
This might be an insult to the German people.
I'm sorry, Germans!
Yes, as you should be. So, she was also introduced to Otto Hahn, who was looking for a physicist to collaborate with. So, Otto had studied radioactive things in the past and was already credited with the discovery of what were thought to be several new radioactive elements. So, Otto and Lise were about the same age, which isn't super notable, but I feel like it's important to the story later on to note that they're on very equal playing fields. They are equals, they're collaborators. She is famous for basically setting up the next guy to discover the nucleus of an atom.
I see.
And he discovered a couple radioactive elements. Who's really more interesting at this point?
I see.
But
so both Lise and Otto were unpaid in their research and used a room in the basement that was supposed to be for woodworking shop for their main laboratory. They had borrowed space in someone else's laboratory upstairs since they couldn't conduct real research in the basement. Otto did a lot of work with trace isotopes and radioactivity, and the chemistry department was yeah, you can't see it, so it's not real. Honestly, if I was them at the time, I understand why. But as we are in an advanced age,
It just blows my mind.
I'm still really confused how Wi-Fi works. And Bluetooth.
We're not comp sci majors for a reason.
Yeah.
We are biologists at heart, basically.
Yay.
Anyway, so Lise faced a lot of struggles during this time. Women were not yet admitted to universities in Germany, which included Berlin. Lise was not allowed to work, she was allowed to be in the old wood shop, but only because it had its own external, like, outdoor entrance.
That's crazy.
She was not allowed to enter the rest of the entire institute.
Why?
Women.
What? That's crazy!
Okay, but get this. She couldn't even go into the extra borrowed lab space upstairs.
So, what? What?
Literally, anything that she needed to have done up there, she would have to have, like, Otto go do, and he'd, like, have to be like, okay, I did it, here's the results. She wasn't allowed up there. She couldn't even go to the restroom there. She had to go across the street, down the block, to a restaurant to use the bathroom.
I fear I would just pee on the floor. Maybe that shouldn't be my digital footprint. Oh well.
It's crazy. It's crazy. Thankfully, though, within the next year, women were admitted to Prussian universities, which is what Germany was kind of considered part of at the time. So they finally had toilets installed in the building for women. The whole chemistry department is, like, kind of an op here. Like, they were so mad about this. They were trying to
They were mad about women toilets?
Yeah, they did not want her to pee. They did not want her in the building. They did not like her, period, because she was woman. But at least the physics department was more accepting, and she became friends with, like, many of them. So, you know, she had the physics department, if nothing else.
That is... What do you mean she can't pee?
Right. Like, also, I don't understand how they were like, okay, yes, you can do research here, but you're not allowed to go in the building. Like, huh?
Yeah, that's kind of insane.
I don't get it.
I'm still holed up on the fact that she can't pee.
Yeah.
Yeah. So, 1908 to 1909, Otto and Lise co-authored 9 papers. With Otto, Lise discovered and developed a physical separation method known as radioactive recoil, where a daughter nucleus is forcefully ejected as it recoils at the moment of decay. I'm saying those words, but I don't understand them.
Yeah.
So, Otto was more interested in discovering isotopes. If you don't know what an isotope is, it's the same amount of protons in an element. So the number of protons determine what an element is.
You're gonna have to start explaining what protons are.
Oh no. So there are protons, and there are electrons, and then there are neutrons. Protons are the positive atoms, which is the smallest unit of matter. Then the neutrons are neutral, they have no charge. The electrons are negative. And all of the elements are made of different amounts of each of them. So the amount of protons that you have determines what type of element. So, like, helium is 1, hydrogen is 2, pretty sure oxygen is like 6, carbon's like 4,
Yeah.
nitrogen's like 5 or 3. Whatever.
It's 5.
The point is, the amount of protons determines the type of element. The amount of neutrons determines the amount of isotopes. So, say you have, the most common thing would be carbon-12 versus carbon-14. Sorry, I'm, like, explaining this whole thing because I feel like it's relevant.
I think it is.
So, carbon-12 and carbon-14s are like the most common forms of carbon. So you have your regular, I'm pretty sure it's 6? I think 4. 6 or 4. Oh my god, I'm actually, how many protons are in carbon? Protons.
I'll take my guess and say 4.
In
but
carbon.
We'll see.
In carbon. 6. Yeah, oxygen is 8. Carbon is 6.
Yes.
Oh my god, because of 6 carbon ring. I don't know why we're tweaking.
I'm thinking about it like, oh, C likes to make 4 bonds. That's why I said 4. That is not true.
Yeah, no, sorry. 6 carbon. Anyways, there are 6 protons in carbon. And so a normal, just like neutral carbon would also have another 6 neutrons, making the weight of it 12. So 6 protons plus 6 neutrons equals 12. That's carbon-12. Then sometimes you can have 6 protons and 8 neutrons, which you put those together, that gives you carbon-14. And so carbon-12 and carbon-14 are in different amounts throughout the Earth and throughout the universe. And then they kind of just balance out, and that's how you get the atomic weight that we have on the table. And so Otto was interested in these isotopes, basically same compound, different number of neutrons. That was really long, so sorry.
No, but thank you.
Lise was more interested in radiation. I wish I could explain to you more about radiation emission of radioactive decay. Things break down and then they
Everybody's
emote
familiar with
radiation. They emote radiation.
I was gonna say, people know what Chernobyl is.
Yes, it was that. She was more interested in that. So she realized that radioactive recoil could be used as a new way of detecting radioactive substances. And they ended up discovering 2 new isotopes, bismuth-211 and thallium-207.
Yes. So Lise was also like interested in beta particles at this time, which was already known to be an electron, basically. So they predicted that they would emit some type of characteristic energy like alpha particles. But when Otto and Lise measured the absorption of electrons by aluminum, they were really confused. I couldn't entirely find why they were confused, but regardless, in 1914, this is like later in history, this guy named James Chadwick found that electrons from the nucleus formed a continuous spectrum, which, again, I think what they're saying here is like, you know, like the Bohr model and like how each like atom can like only have discrete energy states or quanta at each like shell.
Yeah.
So Lise was kind of arguing that like it's not continuous because it differs at each like level based on quantum physics theories.
I see.
And basically, at the end of the day, she was right. I don't think she ended up proving this, but like there's a lot of she's interested in beta particles. They're trying to prove things.
I wonder if
it's
this
kind
was
of up
like
in the air if she really proved it or not.
Because I know that there's antineutrinos, neutrinos, positrons, that sort of stuff. I wonder if they had like emitted a different thing. They were like, "What is that?"
Yes, I think they were kind of like getting close to this, and they were trying to characterize a beta particle, basically.
I see. Okay,
and
that
they were
makes
kind
sense.
of unable to fully do that.
So, in 1912, Otto and Lise moved to a brand new Kaiser Wilhelm Institute for Chemistry in Berlin. I don't know what that accent was. But even though the institute had nothing against women, or so they said, they still didn't pay Lise. And she was considered a guest in Otto's lab, even though they were literally equal in terms of research. They started the research together. They were collaborators. They were supposed to be like hand in hand, buddy buddy.
Great. They're both first authors on all their papers.
And then the institute was like, actually, you are here as a treat. A little treat for him. Have fun. Yeah. So, it's rumored that in 1910, she was facing financial hardship after the death of her father in 1910. Right. And out of fear, she would have to move back to Vienna. So Planck, Max Planck, as in Planck's constant, appointed her as his assistant. And she basically graded student papers, and like this was her first like paid position, but
she got a PhD and then some.
She was literally a whole physicist. So it was literally the lowest rung on the academic ladder, and Lise was the first female scientific assistant in Prussia. So she had her whole PhD. It's like being severely overqualified. She was severely overqualified to be an assistant.
And literally no one else assisted before her. Like, what? It makes no sense to me. But, okay. So, a year after becoming part of the Kaiser Institute, they finally promoted her to an associate, like Otto, but, of course, because it's so early in time, her pay was significantly less than Otto's.
You know, something that's always confused me is why? Why would you pay women less? What is it about being a woman that you're like, they do less in life, so they don't need to be paid as much?
I can't even begin to fathom how on earth that happened, but they thought that they didn't have to pay her as much.
Lovely.
Yeah. So they did at least name the radioactivity section the Lise Meitner lab after the both of them, because I guess she can't have success on her own, according to this university. Soon, though, so royalties from mesothorium, which is basically radium-228, another isotope, also known as German radium, which was produced for medical purposes, which both of them discovered would allow Otto and Lise to no longer worry about finances. But this is where it gets even worse.
Oh, no.
So Otto received 66,000 marks, which is about $513,000 in today money. which is about $500,000, right?
Mm-hmm.
Cool, awesome. He only gave Lise 10% of the money in their joint discovery.
I thought they were chilling. I thought he was her
10%?
friend.
Just for numbers to make things better, that's only $51,000.
I thought they were friends.
He kept $461,700 today dollars.
Otter, why? Otter. Otter, why?
He too, as he proves himself in this story, by story I mean real life, in history, he doesn't value women.
No.
He gave her 10% of $500,000 in today money.
I thought that he was chill.
And she still continues to work with him.
I mean, I can understand that because that's all she's got.
That's
like,
all-
she can't
yeah.
like walk away from that at this point.
No, and everybody in her entire like world is like this, but like,
That sucks.
yeah.
So in 1914, she was offered an academic position in Prague, aka of his homeland. But Planck made it clear that, like, as like head institute person, he didn't want her to leave. He said, stay. So Lisa's salary was doubled to 3 marks. 3K. Sorry, forgot to write the K. Still, 3K, 3,000 marks, which is only $23,000 a year. Hello?
And today money, like,
Wait, so 3K marks in old money, which translated to 23 USK?
Yes.
23,000 US dollars back then, which is actually only 12K right now?
no. So her salary was 1.5 marks. And then Planck was like, bro, we need to keep her to stay. So they double her salary to 3,000 marks. 3,000 marks today is $23,000.
I see, and she used to be only making $12,000.
Yes. So this whole time they were only paying her $12,000 a year in today's money as salary.
Oh my goodness. Hello? And she's not married or anything, right? Like, she's just living alone
It's
by
just
herself.
her. It's just her.
Not that she needs a man, but, like, she could use his wallet.
How are you supposed to afford anything nice?
I don't think she was.
No.
I don't think
She was like living bare minimum, and this guy next to her is like
I've got my $500,000.
literally. Ugh. Anyway.
Disgusting. You want to know what's more disgusting? World War One. So World War One happened, and Otto got deployed right before it. Good, be gone.
But she would have stayed gone.
Yeah. Well, Lise was like, "What do I do now?" So she decided to take classes and become an X-ray technician. She took an anatomy class, and she was like, "Okay, I'm gonna join the Austrian army as an X-ray nurse tech to help people." Slay, very honorable. And so she served in Poland and Italy before going back to Berlin in 1916.
At this point in her life, she's already done so much. It pains me. So when Otto returns in 1917...
Otter? We're sticking with Otter.
Right. When Otto returns in 1917, they were together able to discover the isotope protactinium. She was doing like a bunch of like research when he was gone and it was alone, but like together they were able to come to this conclusion of this isotope.
How do you discover an isotope? I've always wondered that. How do you just be like, this one has more neutrons?
A lot of like electron type stuff and weighing and microscopes and machines I don't understand. Maybe.
Interesting.
I'm probably wrong. Anyway. So Lise was awarded the Leibniz Medal in her own physics section at the Kaiser Wilhelm Institute for Chemistry.
Yippee.
They could no longer ignore her. And then she discovered something else. The cause of the Auger effect in 1922. A year before Pierre Auger published his own work on the exact same phenomenon, although the effect is named after him and not her.
So she found it. He found it later. They still named it after him.
Yes. So the Auger effect is basically where there's an empty part in the inner shell of an atom, and the empty space will be filled by an electron from a more outer shell. The electron moving from the outer shell to the inner shell releases energy, and that's transferred to another electron, causing it to be ejected from the atom instead of an X-ray being emitted. And yes, they named this after him.
Interesting. So this was one of many overlooked contributions during her career, And some scientists now argue that they should rename it the Auger-Meitner effect in honor of both scientists' contributions. At the time, they named it after Pierre Auger because his paper was more specific. Basically, I don't even know. But what are the chances that he possibly read her paper first? It's not that big a world. They were all practicing physics in the same physical sphere.
He had an extra year. That's all I'm saying.
Yeah. Like, that's a lot of days. That's 365 days.
Right, like, I bet I could write my paper better if I copy yours and have an extra month to do it.
Yeah.
Like,
so, back to the timeline, because we have quite a bit more to cover. In 1922, Lise became the first full female professor of physics at the University of Berlin. Between 1917 and 1926, she was also conducting her own research on beta rays. She was the first to say that in the process of disintegration of radioactive materials, the emission of radiation comes after rather than before the emission of the particles. She was named Professor Extraordinaire at the University of Berlin in 1926.
because things cannot get better, unfortunately, her research was interrupted when Hitler came to power.
Why is it always Hitler?
Oh my gosh. Okay, so both of her parents were of Jewish background, and of course she had to leave her work. So, like, thankfully the change in the government didn't impact her collaboration with Otto, but I think that's just because Otto was like, oh my god, like, she's so smart, even though, like, I won't give her real money and
Oh my god.
real anything, actually, but she's valuable to him.
Money
for her brain.
can't make you happy, but it can make you not poor.
Exactly. Quality of life, please. So, early in the 1930s, the world of nuclear physics had made huge advancements. The neutron and artificial radioactivity were discovered. For instance, in 1934, Lise and Otto worked with a group of scientists in Italy who had bombarded uranium with neutrons and found many radioactive products that they thought could be transuranic elements, which are basically elements with an atomic number that's higher than uranium, which has an atomic number of 92.
Sometimes I just think that physicists want to blow shit up. Like, I feel like they're like...
Well, that is where the story's going.
I was gonna say, like, I feel like half the time they're just like, let's blow it up and see what happens.
Speaking of mini explosions, I'm sure that has a role in, like, determining isotopes.
Probably.
I'm pretty sure, but...
Well, Lise and Otto soon found some radioactive substance that couldn't be anything below uranium. So they concluded that these elements were above uranium. This was kind of confusing. It was basically they discovered a new element. So another scientist, Fritz Strassmann, also joined the team at this time. Unfortunately, in the spring of 1938, Austria was occupied by the Nazis. Not cool. Lise had to flee Germany. Flee! So she probably stayed longer than she should have because she had an Austrian citizenship and had been able to sneak across the Dutch border later in 1938, but she, like, left all of her stuff.
Everyone was like, girl, you gotta go. And she was like, nah, bro, my research.
My research!
And then it came down really to, like, okay, we're sneaking you out now.
Yeah.
Crazy. But,
Yeah.
you know, of course, she kept working. Crazy. So, matter of fact, she went all over the place. She went to the Netherlands. She went to Copenhagen. She even visited Niels Bohr and his wife in Denmark. They became, like, besties, low-key. She also went to Stockholm and then Sweden, where she went to work in the New Nobel Institute, where they were building a cyclotron.
That sounds like a transformer.
I don't even know what a cyclotron is, and I fear that I did not Google it.
It sounds like a transformer.
Yeah.
She was doing a world tour. She said, Lisa's world tour, me and my radiation.
I'm screaming. Okay, so let's talk about what's going on in Berlin with Otto and the new team member, Mr. Fritz. So they were still continuing their work even without Lise, but Lise was pretty much keeping up with what was going on. They would send her the data, and she would be like, okay, sick, this is what I think, this is what you should do next. She was the brains, for real.
Mm-hmm.
Not that they weren't smart, but, you know, she had a major role in this team collaboration. So Otto and Fritz did a whole bunch of more tests to try and prove the existence of radium, but they honestly were not successful, and they only found barium isotopes instead.
So Lise was like, I don't know. Let me think on this. So she talked to her cousin, who was also named Otto. Too many Otters. He was also a physicist. Maybe Otto was just a common physicist name at the time. But at least in Otto number 2, we're like, OMG, uranium's nuclei split into 2 pieces. 2! And it just, like, exploded and released a bunch of energy. And they immediately prepared an article for the British science journal Nature, which still exists today.
Mm-hmm.
So, but they introduced the term nuclear fission. Yes! So, scientific principles at this time believed, like, this was impossible. This is a common trend, you'll see. Someone says, this is real, and they're like, no, you're lying. Which, like, I understand, you know, research is research. Sometimes you introduce something for the first time, it doesn't go the way you want. But, she did actually discover nuclear fission. She was for real.
Okay, get this. Okay, so Lise was like, dude, oh my god, there's explosive potential in nuclear fission. Like, remember the big old energy it can release? Yeah, well, basically explosion material. Her discovery is what motivated Leo Szilard.
That looks like Slizzard.
Slizzard, I mean, pretty much. And Albert Einstein, to contact President Roosevelt, leading to the establishment of the Manhattan Project.
So she basically invented the nuclear bomb.
Oh, and she was invited in 1942 to work on the project. And she was like, hell no. I did not discover nuclear fission so you can blow up half the planet. She said, quote, I will have nothing to do with an atom bomb. She was very adamant. It said
she was adamant?
Sorry, she basically...
Atomant?
Adamant.
Atomint.
It's quoted and reported that she said this with very loud voices.
I see.
To further this. But, yeah, so she would avoid any connection to her research with the atomic bomb for the rest of her life because she was like, God darn it, basically. But...
Now we get angry. We get more angry, actually.
If you're not already mad.
If you're not already angry. Because, as there seems to be a trend with so many women of the time, in 1944, Otter, not Lise, Otter Hahn.
Not Otto number 2, not her cousin.
Not her cousin. The original Otter. Received the Nobel Prize in Chemistry for his work on nuclear fission. Did he even, like, use the term nuclear fission?
No. No.
Yeah, no, he...
Maybe in, like, later papers, but she was the first. She got it in the journal first. Like...
Yeah, he didn't mention her at all. He didn't mention her other cousin Otter. Nothing. Nada. He was like, yeah, I discovered this all on my own. I did the project. Oh, her over there, yeah, she's a loser. Anyways, so... How do you... They were besties! Maybe not besties, but they were partners! They worked together for so long, and he never gave her any credit. Like, how does that not crush your soul?
Dude, again, I'm convinced this man had a brain injury. Because a normal person... How would a normal, healthy person forget their collaborator, their partner in crime, for over 20 years? They were working together for over 20
that's, like, insane.
Years.
Yeah, no, that's crazy.
He didn't even mention, I mean, nobody. He took all the credit solely for himself. So, that says a lot about him as a person, not even just as a woman hater, but, like, he didn't even mention his new man colleague, so. Anyway, we don't like him. For a while after 1939, Lise continued to look into fission, but in 1950, she was completely independent from others doing similar research, and she then theorized the asymmetry of fission fragments that worked on various aspects of the shell model of the nucleus. I don't know what that means, but basically big things in physics. Yes. The way that the electrons are distributed are not symmetrical, if that means anything to you.
That makes sense.
Yes.
I'd like to think they are. It makes me happier to think that they're symmetrical.
I do agree, but nothing ever is. In 1947, after spending half a year as a visiting professor in the US, kind of touring, if you will, she became a citizen of Sweden.
She really was a world traveler.
Side quests after side quests. She then retired from the Nobel Institute. Also, I can't believe she was working at, like, Nobel-affiliated things and they didn't give her anything, or...
It also, you know, I never really comprehended that Nobel was in fact an institute.
Yeah,
I thought it was just like a secret society. Not a secret society, but you know.
I mean, basically.
Yeah.
Basically. So after this, she went to work in a small laboratory that the Swedish Atomic Energy Commission had basically built for her at the Royal Institute of Technology. Okay, mini, really quick side tangent. I also have a slight, and this is like a conspiracy. It's not even theory because there's no foundational evidence. The fact that she was like invited on the Manhattan Project and she was basically like, no, F you, I'm not doing this. I wonder if that somehow got her some enemies.
Politics.
Yes, I think politics might have played a slight role in her not getting the Nobel Prize.
Interesting.
But that is just my conspiracy.
Nice.
Anyway, so
E equals MC squared. Sorry.
Yes, Einstein. In 1960, she left Sweden and retired to Cambridge in England, and then she died. Oh, she died in 1968, right before her 90th birthday.
No. Yeah. So throughout her life, she earned the 1924 Leibniz Medal of the Berlin Academy of Sciences and the 1925 Lieben Prize of the Austrian Academy of Sciences. In 1947, she was awarded the prize of the City of Vienna. She just like got the City of Vienna.
It was like their city prize, not the fact that it was the city that she received.
Okay, I see. She received the Max Planck Medal in 1949. In 1955, she was elected as a foreign member of the Royal Society for London and the American Academy of Arts and Sciences in 1960. She received the Enrico Fermi Award. I feel like I did not say that right. As well as Auto Number 1 and New Coworker Team Edition Mr. Straussman in 1966. She received honorary doctorates in science from 4 American educational institutions, Syracuse, Rutgers, Smith, and Adelphi universities. And Element 109 was named Meitnerium in her honor.
So Lise literally revolutionized the science of physics. Her participation in nuclear research resulted in the discovery of atomic fission, a term she literally helped create and interpret correctly, mind you, not incorrectly. She entered her field at a time when women in science were not just a rarity, but an oddity, and she overcame the prejudices and preconceptions that she faced in order to make some literally revolutionary contributions to nuclear physics, like
the bomb.
Yeah, I mean, you still learn about fission today. You learn about the discovery of the nucleus. You learn about the Bohr model. She met Bohr. She met Planck.
She met Planck. With them. That's insane to me. Planck. And I don't know why I really like Planck's constant.
He's got a fun name to say. But she even was like, oh no, the war is going. Let me go save people.
Yeah. She side quested as a nurse.
Like,
she said, let me take my physics and my nurse
and through X-ray. All of this, even having to like not even be allowed in the university where she's doing research,
pee.
Not being paid until she was like years into her PhD.
Insane.
She had so much desire and like determination just to like continue on in physics. She didn't have any children. She didn't get married. Like, science was her entire life, and I feel horrible because the way that she was treated her entire life is not the way that she should have been.
No.
So
she was married to science for real.
Yeah. Science did not have a good pocket. It was very shallow.
Science still doesn't have a good pocket.
But it was even worse.
Oh no, it was worse. It was definitely worse.
Yeah.
But
yeah. Anyway.
The end.
I'm gonna go scream into a corner.